Okay, question 1 asks this question: how many positive 4-digit integers are there between 1,000 and 999, inclusive? That means you're allowed to include those two numbers. How many such numbers are there that are divisible by 5 with every digit even? All right. Now, before I launch into that solution, I just want to tell you something quite important. And that is the following. Let's have a look at a different problem altogether. Suppose you have 3 towns. I always say use the same example to illustrate this. Suppose you've got 3 towns, and there are a number of roads that lead from one town to another. In this example here, I've got 4 roads, and from B to C, again, suppose there are a number of roads. Like that. So if I ask you, how many roads are there from A to B? You will tell me the answer. So how many ways can you get from A to B? The answer is 4. Then I'll ask you, how many ways can you get from B to C? And you tell me the answer is 5. But now if I change the question and say, in how many ways can I get from A to C? There are 2 processes involved here. Right? From A to C. Now, you might say, well, it's 4 plus 5, which is 9. That'll be wrong. So here's how you count it. What you do is you take the first road, let me put a tick here, the top road, and say, I'm going to count how many ways I can get to C using that top road. So you can go like this and like that. The same road, top road, second road, top road, third road, top road, fourth road, top road, fifth road. So for this road here, I have 5 possible routes that I can take from A to C. Now, there's nothing special about this top road. I could have done the same thing with this road, and there will be another 5 there, another 5, another 5, and altogether you have 5 plus 5 plus 5 plus 5, which is 20. Right. Observe that this is really 4 times 5. Well, I got 4 here and I got 5 here, right? You'll get 4 times 5. The reason is, for each choice of the first, there are 4 of them, I've got 5 choices of the second. So therefore, since there are 4 choices of the first, you've got 4 times 5 choices for both of them together, right? Now that's a very important principle. It's a counting principle. If I had another town here, right, and I ask you, how many ways can you get from A to D now? Then you'll say, wait a minute, I know I can go from here to here. I can go 4 times 5. I've just done that, which is 20. So from A to C, I've got 20 ways. From C to D, I've got 3 ways. So therefore, I've got, for each of these 20, I've got 3 possible ways. So in that case, I'll have 4 times 5 times 3. Sorry, this writing is a little bit weird. I'm not sure why. All right, so in other words, if you've got several things to do one after the other, and you want to know how many ways can you do all of them together, you simply take each one of them and multiply the whole lot together. So now that brings me to this problem here. You've got how many 4-digit integers? So you have to look at a 4-digit integer. I'm going to put that, you'll see just now why. I'm going to put it into a block like that, 4 digits, right? The 1000th digit, the 100th digit, the tens, and the units digit here. Right? How many of them between 1000 and 999 are there that are divisible by 5 with every digit even? Okay, let's just go to the last part. If it's divisible by 5, then it means that the last digit Right? You know that a number is divisible by 5 if the last digit is 0 or 5. But they say that every digit is even, so the last digit has to be 0. 5 is odd. All right. So there's only one way in which you can choose the units digit, and that is 0. Right. Now, just similar to this problem here, I want to find out how many ways can I choose the 1000th digit. Now remember, this is a 4-digit number, so you're not allowed to choose 0, but you can choose any number from 1, 2, up to 9. But the second part says every digit even. So you're only allowed to choose 2 or 4 or 6 or 8. You're not allowed to choose odd numbers. So the first 1000th digit can be chosen in 4 different ways. Then it will be 2, 4, 6, or 8. Right? So it's very similar to this problem which we just looked at now. The first road can be chosen in 4 ways. Right, now let's look at that. Having chosen this, in how many ways can you choose this one? Now again, every digit is even. Again, you can say 2, 4, 6, 8. But here there's a slight difference because you're allowed to put the 0 here. 0 is an even number. I can't put 0 here. I can't put it there. So in this case here, there are 5 ways of doing it. And similarly, there are 5 ways of doing this. And here we saw there's only one way of doing this because the only number you can put at the end is 0. So you got, it's a similar thing here like this. This can be chosen in 4 ways. And having chosen that, there are 5 ways of choosing those. So the 2 here can be chosen in 20 ways and so on. So the answer is you simply have to multiply all these numbers. And that's 100. Okay. So this kind of problem can occur even in grade 12 because this topic is discussed in grade 12 in school mathematics. It's called, what I told you is called a counting principle. Okay. All right. So that's the answer to the first problem. Let's get on to the second problem. So the second problem, it reads, how many 3-digit numbers have at least one 5 but no zeros? At least one 5 but no zeros. So the question is now, here I've got 3-digit numbers. It's got at least one 5 but no zeros. So you can have, like, for instance, 357. That's got exactly one 5. But here we say at least one 5. So you could have, for instance, 565. That's got 2 5s. Or you can have 3 5s. But you can't have 350. That's not allowed because it's got no zeros. So now, having set the scene, how do you count all these numbers? You can write them down, but it'll take you a long time to write the whole lot of them down. So there must be some way of counting. And we have to do this kind of systematically, right? Let's look at, we'll take 3 different cases. One where it's exactly one 5. And I'll count the number for that. And then I'll go to exactly 2 5s. And then exactly 3 5s. Now the last one, exactly 3 fives. There's only one 3-digit number which has got 3 fives, and that is this one here. So there's only one in that category. But now, where you've got exactly 1 5, how many are there in that one? All right, so let's just have a look at this. I want to put in a 5 here, exactly 1. I don't know where to put it. I can put it here, or I can put it in the middle one, this 1 5, or I can put it in the last one. Right, and now here in the other two, I cannot put a 5 because we said exactly 1. So in the other two, it could be anyone. I'm not allowed to put a 0 as well. So you can put 1, 2, 3, 4, but you can't put 5, 6, 7, 8, 9. There are 10 digits from 0 to 9. 2 of them are not allowed because 0 is not allowed, 5 is not allowed. So in this case here, you'll have 8 possibilities for the second digit, and likewise 8 possibilities for the third digit. Right? You're not allowed to put a 0, not allowed to put a 5, but any other thing goes. So how many are there? How many such numbers are there when the first digit is 5? And the answer is 5 times 8 times 8. As we saw earlier on, 5 times 8 is 40. 40 times 8 is 320. Okay. Now, exactly the same argument can be used for this one and for this one. And these are different because here the first digit is a 5. Here the second digit is a 5. So we're not repeating anything in these three. So here we got 320. No, I'm sorry. Sorry. This 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 is not 5 here. There's only 1 here, and here there's 8. If there's a 5 here, I'm sticking to 5 there, and there's only one number here and one number here. So it's actually, sorry, it's 8 times 8. My apologies for that, because if we put a 5 in the first place, then we're not putting anything else there. So that one is has got only one possibility. So there are 64 of each, right? So the total number here, when there is exactly 1 5, is 3 times 64. That's 192. Okay. Or you could have had the next one. The next case we have to take is where there are 2 5s. We have to count them there. Now, in the case of 2 5s, again, you argue the same way. This time, you got 2 5s. Suppose you got a 5 here and a 5 here, right? So there's only one way I'm choosing this. There's one way of choosing this, one way of choosing that. And as before, there will be 8 ways of choosing this, because you're not putting a third 5 here, right? We'll be counting exactly 2 5s. So there are 8 ways of doing it if the first 2 are 5. But then you could have the second 2 could be 5. Or the first and the last can be 5. Right? So 2 5s, there are 3 different ways in which you can place 2 5s in these boxes, right? And in each one, in each case, there are 8 numbers. So you've got, this is 3 times 8. Right? 1 times 1 times 8. And again, the same thing for that. Here, there's only 1. So now we can count them. We've got, in all cases, we've got at least 1 5 and no zeros. So if you count all these 194 and so on, you'll get 217, which is the answer. All right, so in here is a good example where you have to separate the 3 issues and count them separately. Now, that's a strategy. Now, you have to decide whether you're multiplying, adding, or whatever it is, but you have to think about the problem to decide whether you're going to add or what. In this case here, you take the first case, finish it off. Second case, finish it off. Third case, finish it off. But the final answer will be the sum of those three numbers. Each case has got so many numbers. Okay, so that takes me now to the third problem. Okay, here you've got Faisal leaves home at the same time each day and rides his bicycle to school. Okay, now this is a distance time problem. Usually people, when they see this kind of problem, they get quite frightened. Right? And I notice that teachers rarely tackle these problems because even teachers struggle along with them. So let's not worry about all the fear around this thing. I'll show you how to do it systematically. Faisal leaves home at the same time each day and rides his bicycle to school. So let's get a picture of this. I always like to have a picture. Here's Faisal. He's going to school on his bicycle. So this is Faisal's home here, FH, and this is Faisal's school. Right. So he rides his bicycle to school. Okay. He's going from there to there. School begins at 8 o'clock each day. All right. So just bear that in mind. It starts at 8 o'clock. If he cycles at 30 kilometers per hour, okay, let's take this case here. If he's traveling at 30 km per hour, he arrives 10 minutes early. Now, how are we going to translate that? Okay, let's continue. If he cycles at 15 kilometers per hour, he arrives 10 minutes late. So the question is, at what speed should he cycle in order to arrive exactly at 8 o'clock? Right, let's just do the same thing. In one case, he's traveling at 30 kilometers per hour. The second case is traveling at 15. And the third case, we don't know what speed is going to travel. But what this problem is saying is that when he travels at 15 kilometers per hour, he reaches school. Here, he's traveling fast. He's 10 minutes early. Here, he's traveling slow. He's 10 minutes late. And in this one here, the question is, at what speed should he cycle in order to arrive exactly at 8 o'clock? So we don't know what the speed is. Right? We'll call it B. I usually use the symbol B for speed, because S can be used for something else. V stands for velocity. Okay, so we don't know what speed he has to travel, and we don't know how long it takes him. So let's say that you want to reach the school in T minutes, right? When he's traveling at speed V. So now we can actually calculate what the distance from the home to the school is. Because there's a very important formula, which I'm sure many of you have seen. Distance equals speed times time. It's quite obvious. If you're traveling at 80 kilometers per hour and you travel for 2 hours, you'd have traveled 160. Oh, so 80 kilometers per hour. This is speed. This is the rate. And here, this is in hours. And this is in distance, kilometers. Right? So here, if the speed is v, so in this case, the distance from, suppose, let d be the distance from home to school. Sorry, this writing is looking so bad.
Okay, it's like I'm
I have an
muted.
excuse. I have an excuse because my writing is generally bad. This time I can say I'm left-handed, you see, so it's hard for me to write like this. Okay, so we have from the last one, we got the D is equal to B times T. So I've got my unknowns now, T and B, but we really are interested in that one. No, wait a minute. You're interested in that one. What's the speed? I don't know what B is. Okay, so we've got three unknowns here, D, B, and T. Now, let's look at the first piece of information. Here, he reaches 10 minutes early. In other words, instead of taking T hours, let's call it hours. This is hours. Because it says kilometers per hour. Right? So the time should be, and here it should be kilometers. Okay. Now, if he reaches 10 minutes early, that means he reaches it 10 minutes is 1/6 of an hour. So he takes T, which is what he would have taken ideally, but is taken less time to reach school, T minus 1/6. And that's when he travels at 30 kilometers per hour. So this is the distance between the school and his home, right? And in this case, if he traveled at 30 kilometers per hour, he would have taken that amount of time. And the other one is 15 here, but it takes 10 minutes more here because it's traveling slow. So here it's T plus 1/6. If you think about it, this is what is happening. He would have reached in time, right? If he had traveled, if he had traveled, he didn't reach in time. So this is the distance he has traveled in that same period. So you've got that, and this is equal to BT. Now, you've got a couple of equations here. All of them refer to the distance. Let's not worry about that now for the moment. But here, you've got one equation in one unknown. I'm not going to do it, but when you calculate it, you see the T is equal to half an hour, which is 30 minutes. Right. But that is not what we wanted. We wanted to know at what speed he must travel. Right? At what speed he must travel. So we needed to know what B is. So we got T is equal to half. So we can look at this equation here now. This is where the V is. So what is D? When T is equal to a half, you can put T equals a half here. A half minus 1/6 is 1/3. So you'll see that D is equal to 30 times 1/3, which is 10. So D is equal to 10. You can substitute T equals half there or there. In both cases, you'll get 10. And we already know that T is equal to a half hours, right? So that now tells you what it is, that B is equal to, D is equal to, let me write here, 10 is equal to B times a half. I'm converting everything to hours, and therefore B is equal to 20. That is kilometers per hour. See? This is very misleading. You got 30 and 15. Your first guess will be, well, it's going 10 minutes late, 10 minutes early. So therefore, you will travel at the average of these two speeds, which is 45 divided by 2, which is 22.5 kilometers per hour. And that is not the answer. See? So one has to be very careful with these things because distance, that you have to use the master formula, the distance is equal to speed times time speed is equal to distance over time. and time is equal to distance divided by speed. Then you get a different answer altogether, not 22.5. Okay, so the answer to the problem is 20 kilometers per hour. Let's go on to the next question. Okay, so this problem says start with a small square of side length 1 centimeter. Okay, let's do that. Let's draw the square. The nice thing about this app is that you can draw squares very quickly. Okay, so let's start with that. And the side length of the square is 1. So we'll just put 1 here. Now create a second square with the diagonal of the first square. Okay, now this is your first square, and you're going to create a second square using your diagonal. So let's draw a diagonal. And then, so using that diagonal, you create a second square. So on top of that diagonal, you put a square. All right, so you got a new square. Started off with 1. So let's see, by Pythagoras, the side of the square is a diagonal, which is really the hypotenuse of this right angle triangle. So we can calculate the side of the second square. First square has got side 1. The second square has got side square root of 2. All right. So, but it says and so on. In other words, you take this new square and you draw a square on that one, the diagonal of that one. Right? Each time you draw a square, you draw a new square on its diagonal. So you can see the squares are going to get bigger and bigger, right? There's no space to draw the whole lot of them. But let's just see what's going on here. What's the question? Which square will have the first square with an area greater than 2020? Okay, so this problem is about areas. Okay, so let's just look at the area of the first square. Area is 1 times 1. The area of the second square is square root of 2 all squared. That's a side, and that'll come to 2. So what we see here in this particular example is that the area of the second square is twice the area of the first square. All right. Now, if I do that for the second square, do the same thing all over again, then I'll have a new square. So let's just take a general case. Instead of calling this 1 and 1, suppose we say, let's just take any square of side A. We'll call it A. And because there are quite a few, the same process is repeated several times. So let's just take a general case. This is A, and that is A. And then again, according to Pythagoras, this is square root of A squared plus A squared, which is 2A squared. So that's the diagonal. And the area of a square whose side is square root of 2A squared, the area here is 2A squared. Okay, so if you had the new square as area 2A squared, and the original square was A squared. So what has happened is, which is twice the area of the original. Now, this is the power of mathematics. I'm not specifying what A is, but I know that I will always have the new square is going to be twice the area of the old square. Now you can see it worked like this. Now you got the first square got area 1, and the second square has twice that area. So like that now, you can go on for the new square will be twice that area. And you go on. And the question is, which is the first one which has got area greater than 2020? So you're going to get all powers of 2 here. And one of the powers of 2 is 1024. And the next one is 2048. So which will be the first square with an area greater than 2020? This will be the first square. All the other ones are smaller. And if you keep going on, the next one will be twice that, right? So that is also greater than 2020. That is why they say, which is the first square, right? This is the very first square whose area is greater than 2020. You simply have to count it. Now, this is your first, second, third, fourth, and so on. And you can figure out at which number that occurs. All right, so that is how you solve that problem. You have to know which square will be the first square. You have to answer the question and see which square. I think it's the 11th or the 12th or something. Okay. So that takes me to the next problem. This problem oh, now consider a regular hexagon. Okay, let's just stop there. What do you mean by a hexagon? And what do you mean by regular? Okay, if you need to understand what these terms are. In general, an hexagon is a 6-sided figure. But so you could have a regular triangle. So regular means all the sides are equal, right? So a regular triangle, for instance, is Mr. Ahmed, please don't draw on my screen. A regular triangle is a triangle with all the sides equal. And of course, you know what that is called. It's called an equilateral triangle. A regular quadrilateral is all the sides are equal. Oh yes, all the sides and all the angles are also equal. So a regular quadrilateral is a square with all the sides equal. So here too, you've got a regular hexagon, which has got 6 sides, right? All the sides are equal and all the angles are equal. Okay. Now D and H are the midpoints of the respective sides. So you got D is a midpoint here, it's a midpoint here. The fraction of the hexagon that is shaded. Now you've drawn a couple of diagonals. You've drawn that diagonal, and that diagonal, that diagonal. And in between here, you've got a couple of shaded part, and you are asked to find the area the fraction of the hexagon. In other words, what is the ratio of this shaded area to the whole area, the fraction of the hexagon, right? That is shaded is P over Q. So now we need to calculate what is this area in terms of the full area. What is the ratio? Okay, so before we proceed to that, I need to tell you something about regular hexagons. They're very beautiful geometrical pictures. And Okay, now, so here's a regular hexagon. It's kind of hidden inside here, but this is the. Let me just highlight that. So. Oh, it's not highlighting. All right, there it is. So there's your, all the sides are equal. Now, the nice thing about these regular pictures is always, whether it's a regular quadrilateral or a regular pentagon or anything, these things have got a center, which means that there is a circle which can be drawn in such a way that all the vertices are on that circle. Right? The circle has got a center, and the center of the circle is the center of the figure. You can try it in a triangle, in a square. You can try to find out where the center is, or a pentagon, regular pentagon. These are all interesting exercises. But so this thing has got. I've actually drawn the circle, and I want to find out some properties of a regular thing. I got a couple of diagonals here, and I need to know a little bit more about what these diagonals do. Okay, now please, you've been asked earlier on, if you weren't in the class, please be informed right now that you must switch all your audios off. Your mics must be off. Please do that, and don't disturb the class, because if anybody disturbs the class, I'm going to ask David, who is my helper, to take that person out of the class. So please be warned. I'm not going to say this again. Okay, so all the sides are equal. Let's just call it A. Or instead of doing that, just put these all equal. Right. Now, there's a very important property of circles. Some of you would have done a little bit of circle geometry, but I'm going to just tell all of you, you should remember this. If I've got a circle, that's kind of squeezed in there. Just draw a bigger circle. An important property of a circle is the following. You see, if I draw a chord of a circle is a line that joins 2 points on the circumference. So suppose I draw 2 chords. Let me draw one chord first. This chord, it divides a circle into a small part and a big part, right? Except the diameter divides it into 2 equal parts. But suppose I've got 2 chords which are the same length, and you will see like that. Then it turns out that any angle, if I take any point on the circumference, now this angle here is called the angle subtended by that chord at the circumference. Don't worry about the big language, but just remember you've got 2 points of the chord on the circle, you get a 3rd point on the circle, and you're looking at this angle here. Now this angle here, interestingly, is going to be and if you do the same thing with this chord here, you take any point on the circumference and join it like that. It turns out these angles are the same. If 2 chords have got the same length, then the angles that they so-called subtend are equal. So this angle here, if this angle is x, this angle is also x. See? Now, why am I saying all this? If I start off with this chord here, and I want to look at this point here, let this be the 3rd point. So these two, you go up there, let's call this X. That angle will be the same as, now there's another chord which is equal, and you go up again to the same point, and this X, they'll be equal. And if I take this thing here, which has got the same length because it's a regular polygon, and I go up to that point, it'll come back again. Again, that's X. And you take this one, and you go up there, you get X. So all these angles are equal. That's a very useful thing. Now also, in any polygon, it's one of the remarkable facts about polygons. Sorry, pretty mutilated polygon that I've got there. I'm just lazy to draw straight lines. All right. If I take some polygon like this, okay, in this case, I've taken a 5-sided polygon, which is called a pentagon. Now, interestingly, if I take a side and I extend it, now from here, I take that and extend that. From here, I take that and extend that. From here, I take this and extend that. From here, if I take it and extend that, I've got 5 new angles. The interesting thing is that these angles will always have the same sum. They'll always add up to 360 degrees. It doesn't matter whether the polygon is regular or irregular or whether it's got 100 sides or whatever. The number of sides doesn't matter. But when you do this thing, you extend and keep going around and around and around, eventually you'll come, when you add up the whole thing, you'll get 360 degrees, right? So in a hexagon, you've got all the 6, what you call the exterior angles. If I produce this a little bit like that, right? All these things are equal, and there are 6 of them, because all the internal angles are equal, you see. So therefore, the external angles will also be equal. 6 of them, they add up to 360 degrees, so this part here will be 60. When I extend it, this is 60, so the inside here will be 120. Okay, and the 4 of them add up to 120, so each one is 30 degrees. Okay, so now that's very useful, because now I can calculate all the angles that I see in this picture. Right? I don't want to do the whole lot, but just remember that each time you have a particular side subtending, it's 30. It subtends 30 degrees, right, at that point. So you can. This happens at all this. So therefore, in particular, you will have that this angle here is 60 degrees, right? Now remember, this is a radius of a circle, so the 2 radii are equal. So you have an isosceles triangle sitting here. And if that is 60, then this is 60. Right? But now, it now becomes an equilateral triangle because it's 2 of them are 60. And you'll see that this angle is 60. And likewise, you can do that to all these. So all these angles are 60. So you'll have, these are equilateral triangles. So from here, if I go up to 2 adjacent points, I'm going to get an equilateral triangle. Right, so that's an important fact to observe. Right? The second important fact I want to show you is, you see, this is 30, this is 60, so this is 90. So if I draw a line like this, going halfway, dividing this hexagon into 2 equal parts, and I join this, that will be perpendicular to this. Now, why am I saying all that? Because in this picture here, You see this line here? This line here divides the hexagon into two equal parts. And this is an example of that line which we had there. So therefore, this is 90 degrees. See? That angle is 90 degrees. So all these angles are 90 degrees. Okay, so in this picture now, I've got one of the angles. Now, I'm trying to work out the area of this the shaded part. So to do that, I'm going to actually complete this, join this to that. Now remember, we just proved that this triangle here is equilateral, right? And this one here will be an altitude for the equilateral triangle. It's perpendicular. Right. Now, this line here, by the way, this angle here is 30 degrees, right? The one that I'm pointing to here. Because from this is the side which subtends here, is 30 degrees. The whole thing is 120, so this is 90. So we can calculate that angle. It's 90. Why do I say that? Because this will also be 90. And these are parallel. So you got a rectangle here. Okay. So in particular, I've got in the small picture here, in this triangle, I'm really interested in the small triangle because this shaded part is part of this triangle. Now I've drawn the triangle here. See on this side, I've drawn an equilateral triangle and I've drawn two perpendiculars like that. And it turns out that the third perpendicular also goes through this point. And this is a useful fact in geometry, that all the altitudes all go through the same point. But more than that, all these areas are equal, see? Because these two are equal, because they got the same height and the same base. Those two are equal, those two are equal. And it turns out that these two are equal here because these two triangles are congruent. So I'm not going to go into all those details, but I'm just telling you that these two triangles are congruent. You can check it out. So the congruent triangle, they've got the same area. So you see that a whole lot of them have got the same area. So this shaded part, let's call this S. It's the same as this, as you can see, right? Now the S is, I needed to find the area of the shaded, the full shaded part, and it's equal to, let me just create some space here. Okay, the idea is to find the area of the shaded part. So I just saw that this is S, and each part is 1/6 the area of the triangle. So the S is 1/6 of the triangle. All these things are equal. And you got two S's, right? So the shaded part is 1/6 area of equilateral triangle. Well, actually, it's 2/6. There are two shaded parts, which is 1/3, right, of the equilateral triangle. And each equilateral triangle, I told you that the original thing here is divided up into 6 identically equal triangles, equilateral triangles. So each equilateral triangle is 1/6, 1/3 times 1/6 area of hexagon. With each equilateral triangle, all these triangles are congruent. All got the same radius and so on. So they've got the same area, and therefore each equilateral triangle is 1/6 the area of the hexagon, and the shaded part is 1/3 the area of the equilateral triangle. So the answer is what fraction? is it? It's 1/6 the area of the hexagon, the shaded part. And that was the question, right? Question was, what fraction of the of the hexagon, what fraction of the hexagon is it shaded? So we've just worked out it's 1/18th. P over Q is 1/18. And therefore P plus Q is the simplest form. It has to say it like that. The 1/18 is the same as 2/36, and so on. So the infinitely many ways of writing 1/18. So the simplest form is 1/18, and that form there, P plus Q. See why it says the simplest. So P plus Q is actually 19. Okay. Yeah, simplest form. Shaded. So you see, you have to read through this thing carefully and know all the words. See, so I've got all these words here. You have to first understand what the words are, and then tell yourself what is the problem, and try to solve the problem. Okay. So the next problem, again, it's a problem on areas. Let's determine the ratio of the sum of the areas of the shaded squares, the area of the largest square. Right. The area is, nothing is given. No sides are given. All you are told is that there are 4 squares here. Right? And you're building these squares in a particular way. You draw a square here, and you've got another square which is sitting here, another one there. Now, what ratio is that? So now you have to work out the area of the green part, right? So how do I start with the area of the green part? So let's start with this square here, the smallest square, and suppose the side is A. Now listen very carefully, yeah? Because I'm going to go do a lot of little geometry things here because there's lots of geometry going on here. And just follow what I am saying. So I'm starting off by saying, let the area of the smallest green square be A squared. In other words, let the sides be A. So all these, this is A. Right. Now, here's a good observation. You see, this is a diagonal of a square. And whenever you've got a diagonal of a square, only in a square, these two are equal. A square and a rhombus also. Only in a square and a rhombus, the diagonals bisect the opposite angles. Right? In a rhombus, bisects the opposite angles, but in a square, the opposite angles are 90 degrees, so you know exactly what these values are. They're 45, 45. Okay, so this is 45, and this is 90 degrees here because this is a square. So therefore, this is also 45, which means that this part here is A. We've got an isosceles triangle here, a small isosceles triangle. All right, so now I'm creeping along the side here. Now here, I've got a new side. I don't know what the side is. It's longer, the previous one. Let's call it B, right? Now, I want to find out what this is. Ultimately, I'm going to get all the sides in terms of A and B. Right, so you must just watch slowly how this is done. This triangle here, these two triangles, for one thing, they're right angle triangles which have got equal hypotenuses. Right. So two things in those two triangles are the same. But are they congruent? You need a third thing. The third one, it turns out that these two angles here are equal. And this is an important fact. It occurs very, very often. When you got a right angle sitting on a straight line, then these two angles are complementary. They add up to 90 degrees. So here, you will see that this angle and that angle are complementary. So this angle is 90 minus this, But 90 minus this is also this, because you got a right angle triangle. Right? So this angle is 90 minus. So you got these two triangles are congruent, which means that this becomes A. Joe Cole, please take your mic off. Sorry, David, I will have to ask you to take the person out of the class.
Yes, I'm busy with that.
They don't follow instructions. Okay, so you got these two triangles are congruent. So this must be equal to this, and this is equal to B. Right? That is a two triangle congruent, so all the sides are equal. The sides of one triangle are equal to the sides of the other. So okay, we crept along this. Now we see that the side of your original square is 3a plus b. So that's nice to know. Now, where do we go from here? And this, to continue with this, you have to perform a small construction here. What we have to do is to just extend this to meet that one. And now you have a new small triangle. And I'm not going to go into the details of this, but it's very obvious. You got a similar situation. And again, you got 90 degrees here. So you will see that it's like that, AB. See? Now, in this picture here, you got a rectangle. So all these are 90 degrees. And so that will be equal to B. So that will be equal to B also. Right. So you see, actually, you got a square because this is also 45, you see. It's 45. This is 90. So therefore, that other one is 45. So these two are the same. Okay, and that is B there also. All right, now I've got sufficient enough information now to solve my problem. I'll tell you why. I've got sufficient enough information. Let's see, the area that we are looking for the question is determine the ratio of the sum of the areas. Right now, you got 3 areas there. And do we know the ratio of the sum? Okay, so if the ratio is a fraction, I'm going to put this shaded area at the top, the ratio of the shaded area to the area of the largest square. The largest square is, you can see this part here is 3a plus b. That's a side. And the area of that is 3a plus b all squared. The area of the largest square goes at the bottom. And the area of the shaded part, this part here is a squared. Right? And this part here, what's the area of this? Now the area of this is the square of that. And we've seen earlier on, this is the square of the hypotenuse. And by Pythagoras, the square of the hypotenuse is the sum of the squares of the other two sides. So this green square here is the square of this, which is a squared plus b squared. It's the square of this because it's the area of the square, you see. And then, so that takes care of this large green square. And then you got this other small square, b squared. Oh, but now you've got a problem now. We don't know what a and b are. So how are we going to solve this problem? And this is where a little bit of ingenuity comes in. This thing is the side of a square. This is also the side of a square. So therefore, these two sides are equal. Now watch. The top side is 3a plus b. But this is not 3a plus b. This is a plus 2b. Right? Which means that you got an equation here. So 3a minus a, if you bring it to the side, is 2a. And 2b minus b is b. So b is equal to 2a. Okay. So you got b in terms of a, which means I can replace all these b's here by 2a. So I have a squared, that's a squared. B is 2a, so it's 4a squared, 4a squared. At the top, I've got 3a, b is 2a, all squared. And then the top, you've got 4 plus 4, 8 plus 2 is 10, 10a squared. The bottom, I've got 5a all squared, which is 25a squared. And magic, the a squared dies, disappears, and the answer is a beautiful 2 over 5. So the ratio of the sum of the squares is 2:5. So that's the answer. You can put 2 over 5, but some nasty people might take out a mark for that. They asked the ratio, not the fraction. So you can say the actual answer is 2:5. Okay, so that's a nice problem. A little bit of geometry involved there, involving congruence of squares and so on. But you can see step by step, if you just follow it through without being quite patient, you can solve the problem. Okay, I'll get on to the next problem now. I'm racing through all these problems because I'm assuming that you have already done these problems. These problems were sent to you on Friday. I'm not sure if it's Friday or Saturday, but today is Wednesday. So you would have had a couple of days to have a look at the problems and try them. If you have not tried them, you have lost out a lot because you're sitting here and just listening to answers without even knowing what the question is, which is very unfortunate. You can't learn any mathematics like that. You have to know the question. You have to try it out. It's fine. If you try and fail, it's fine. But you must try to understand it, and that is when you will benefit from these classes. So just make sure that next week when you come, you try out those problems. Okay, so we're going to question 8 now. It's given here that Mbali and Pretty both have 1 rand coins in their purses. And both want to buy a chicken pie separately. All right, so they want to buy a chicken pie and they've got a certain amount of money. But Mbali is 4 rands short. Okay, so let's just give a name to how much of money Mbali has. Suppose Mbali has got, I like to give understandable symbols. So I'll put M rands. I don't put X. Then I know this is Mbali's money. She's got M rands. And Pretty will have P rands. Right, so now, Mbali looks at a person, she's got M rands, and she says, oh, I'm 4 rands short, man. So I need another 4 to get to the cost of the pie. Right? So you have to add another 4 to it to get to the cost. Now Pretty has got a little bit more, it seems, because she only needs 3 more to get to the cost of the pie. All right. And then they decide to combine their money. So you take, she's got that. M plus P plus 7. That is when they combine their money. Right. Now, that's not the cost of the pie. They see that they are still they're still short. Okay. So this part here is still smaller than the cost of the pie. All right. So now the question is what is the price of the chicken pie? How does one do this? So we don't know what the price cost of the chicken pie is. So let's call it cost C. And this is C. C. All right. So you got that M plus 4 is smaller than C. And P plus 3 is also smaller than C. Both of them are equal. Because both cost. Both of them are the cost of the pie. So I got M plus 4 is equal to P plus 3 because both of them cost, this is the cost of pi. So from here you can get an equation because P is equal to then M plus 1. P is equal to M plus 1. So what do you have here? You've got P is equal to M plus 1. So let me replace that P. I'll get 2M. P is M plus 1, 2M plus 8 is smaller than the cost of the pi. So this is smaller than M plus 4. Why am I saying it's 2M plus 7? Oh, P is M plus 1. Okay, so I think you can do it by trial and error. Uh, okay, let's try. See, Mbali has got a few 1 rand coins. So let's just try M equals 2. It can't be 1. M can't be equal to 1. So suppose M is equal to 2, then you will have Mbali has got 6 rands. I mean, the cost of the pie is 6 rand. She's got 2. She's running short of 4, so the pie cost is 6. And Pretty has got, then Pretty will have M plus 1. So Pretty has got 3. And now when you combine these two, you will see that they're still running short. See? So, so this is a possibility because they are, but if you put M equal to 3, then you'll have 3 and 4, and 3 plus 4 is 7, then you will have enough, you see. If you start increasing M, you will have more than, see, this is always 4 more than that. See, 2 plus 4. So you will have, if M was 3, then the cost of the pie is 7, and now you'll have, this is 4, and you'll have 3 and 4, and 3 plus 4 is exactly equal to 7. And they're not running short. So there's an actual way of doing this thing mathematically, but I forgot how to do it. But you can do it by trial and error. So M equals 2 works, M equals 3 doesn't work, and M equals 4 and all the others don't work. So the answer is M equals 2. Bali has got 2. And she's short of it by 4. And the cost of the pie is what they wanted. So the cost of the chicken pie is 6. 6 rands. Okay. So the idea is that if you put all these things together, you will see that when you substitute different values for M and P, you will get something. See, the other way of looking at it is that M plus 4, or you can say 4 is less than or equal to the cost. Oh, all right, it doesn't really matter. You have to try chicken, try by trial and error. All right, and that will work. There's a nice, clever way of doing this thing here without trial and error, but I seem to have forgotten how to do it. Okay, let's now get to the next problem. The next problem, question 9. Okay, question 9. A train takes 15 seconds to go past a telephone pole. Right? I don't have too much of time, so I'm going to go briskly through this. The same train takes 45 seconds to cross a bridge, which is 450 meters long. So let's just do it one step at a time. So you take the train, if it's to cross a telephone pole, it takes 15 seconds. So let's just draw the telephone pole together with the train. I'm battling to get this thing in here. So suppose this is your telephone pole. You got a train. Oh. So let's just draw a train here. There's your train. So when you're observing it, there's the front of the train. The front of the train, right? It takes 15 seconds to go right across. So if this is where the engine driver is sitting, the engine driver will be sitting here, and the back of the train will be here, right? And this whole business takes 15 seconds. So exactly how far has the engine driver moved? If L is the length of the train, right? So it means that the distance L, we're working in meters, right? So let L, I'm introducing a symbol, so you must state what it is. Let L be the length of the train. That's a question, by the way. Train in meters. Right. So the it moves L meters in 15 seconds. So its speed is L over 15 meters per second. Right? It covers 15 meters. Distance over time is equal to the speed. Right. And anyway, this just by logic you can see its speed will have to be L over 15. Right. Okay, now it now crosses a bridge, which is 450 meters long. So the train comes up to this point here, and it crosses the bridge at this point. And how far has the train moved? Well, you have to see how far the engine driver has moved. The engine driver is here now. The beginning he was here. So this is L. So the engine driver has moved 450 plus L. 450, this is the length of the bridge, together with that. And that, it took him 45 seconds. to do that, right? And therefore, his speed here, the speed here is distance over time, but it's the same speed as what we had earlier on. So this is L over 15. See? So you got a simple equation, and L can be calculated very quickly because this is 15 is 45 is 3 times this, so this is 3L over 45. I can do it like that to get the same denominator. So therefore 3L is equal to 450 plus L. Denominators are the same, so the numerators are the same as well, and that gives you L equals 225 meters, which is the length of the train. Okay, so that wasn't a very difficult problem. Okay, now you get to something which is a little bit more demanding. In the solar system, Mercury takes 7/30th of a year. Venus, 13/21 of a year, and Earth, 1 year to revolve around the sun. All right, so Mercury takes a very short time to revolve around the sun. That's because Mercury is closest to the sun, right? And it's got a smaller path. All of them are elliptical paths, which is not so important, but just for general knowledge. And Venus is next. Mercury takes 7/30. That's smaller than a quarter, and this is more than a half, so that's 13/21. And Earth takes 1 year to go around the sun. We all know that. Okay, so this is 7/30. Now let's understand all these things. It says here that in the year sometime in 2019, the Sun, Mercury, and Venus were all in the same straight line. So that's interesting. These three, together with the Sun, the same straight line. The Sun, we'll assume the Sun doesn't move. Okay, so that the Sun is fixed. So in which year will this exact same phenomenon be repeated? Okay, in other words, the question is, when will this situation arise again? Okay, so we have to translate this information nicely and say, what do you mean by 7/30 and 13/21? So let's just take take 7/30. What does this mean? That means Mercury it takes 7/30 years to complete 1 revolution. All right. So, so after 7/30 years, so many months, it's here. And again, after so many months, it's back here. So it keeps the number of times after several months, it comes back to the same position. So it means that it returns to position, returns to start always after 7n/30 years. See, after 1 year, 7/30. Then the next one, not after 1 year, after 1 revolution. The next revolution is another 7/30. So each time to come back to start, it's a multiple of 7/30. Right? And the other one, Venus, again, it returns to start at 13 we don't know how many, 13m over 21 years. Okay. So we want them to be at the same position, right? When will this happen? So you want this, you have to choose n in such a way, and m, such that they're both at the starting position, right? So if it takes, so after 1 year, other way of looking at it is, after 1 year, it's made 30 over 7 revolutions. And the other one, that's Mercury. And Venus, after 1 year, it's made 21 over 13 revolutions. Right. So in other words, after 7 years, it makes 30 revolutions. It comes back to the start. So Mercury returns to the start every 7 years. Sorry, my writing is not very clear. I apologize for that. So because it's 1 year, it's 7 over 30 revolutions. 7 years, it'll make 30 revolutions. It means it comes back to the start. And the same with Venus. Venus, it returns to the start after every 13 years. So you want both of them to be at the starting point. So after how many years will that be? So you have to see which number both 7 and 13 go into. See? Because after it returns to the start after every 7 years. So Mercury will return after 7 years, 14 years, 21 years, and so on. And Venus, 13 years, 26 years, 39 years, and so on. And you want them to both be in the same position, right? So you'll need to find out when do these two numbers are exactly the same. It turns out that the smallest number of years will be 91. It will be 7 times 30. And after 91 years, this 91 will be in the sequence, and 91 will also be in the sequence. So they both will be in the same position after 91 years. So the question is, in which year? And the answer is 91 plus 2019. Must answer the question. So after 91 years, so 2110. 2110. All right, so this will happen in all probability when all of us are dead. Right? 91 plus the minimum age in this class, or somebody might live up to 103 or something. All right, so there we go. I certainly will be nowhere near the scene at that time. Let's get to the next question. Okay, now we've actually come to the end of the time, 6:30. Those of you who want to go away, you're quite free to go. But I'm going to finish this thing off. I'll try to finish it up as quickly as possible. Okay, that's a promise. Okay, now here, I'm not even going to describe everything here. You need to find the area of the yellow part. But you know that the radius of each of these circles is 2 centimeters. So how do you find the area of the yellow part? The strategy here is the white part, the radius is 2. So this is 2, that is 2, that is 2, that is 2. So you can work out the area of the semicircle. The full area, because it's half a circle. So it's half pi r squared, and the radius is 4. So the area of the pi r squared, so this is 8 pi. So the area of the semicircle, you know. And now, so the area of the yellow part plus the area of the white part is 8 pi, in other words. So if I know what the white part is, then I know what the yellow part is. So what is the unshaded area? So that is what we need to calculate. All right, I already got this part here. In fact, these two together give you a full circle. But if you don't want to do that, this is half pi r squared. The radius is 2 here. So 2 squared is 4 pi. That's the area of the full circle. So this will be 2 pi. That will also be 2 pi. The area of the full circle is pi r squared. The only thing is, now you can work out the area of that. But what about this area of this funny part here? Now that's the problem. We can't work out the area of this funny part. Right? We don't have any formula for that. So we'll have to, we can't use this strategy to work out the 3 semicircles, and then you got one bad guy there. We have to think of some other way of calculating the unshaded part. And the way to do that is actually split this down the middle to get a rectangle. Right? So what happens now, I can divide this white part into 3 parts. Instead of using the funny part, you can break it up into pieces whose areas you know. Area of a rectangle I can calculate. This is the area of a quarter circle, area of a quarter circle, area of a half circle. So these outside things gives the area of a full circle, right, which is pi. And of course, this radius is 2. So that's the area of that is pi times 2 squared, pi r squared, because you got 2 quarters and a half. And here the area of this, well, this is still 2 because this is the radius. And this part here is 4 because you got 2 and 2. So the area of the rectangle is easy. It's pi plus 8. Right? So the area of the rectangle is 8. So the area here is just 4 pi plus 8. This is the area of the shaded, the unshaded part. So the shaded part is simply taking the whole thing and subtracting the unshaded part. And that is the answer to that question. Okay? I'm sure you could have done that. So it's not such a difficult problem. But the only thing is you have to notice that you have to break this thing up into areas which you can calculate, not to have nasty areas like that funny little thing there, which we saw just now. So you break it up into rectangles and quarter circles, and that you know. Okay, now we go to the last problem. 2 real numbers, x and y, are given with 0 less than y less than x. So y is smaller than x. And you know that x plus y over y plus x is 8. And the question is now, what is this thing here? Right. So that here, this is another nice problem where you have a strategy. And the strategy is, we've got 2 unknowns here. But what I'm going to do is I'm going to give a name to this fraction. Let x over y be equal to t. Let's call it whatever you like. I'm going to call it t. Now bear in mind that y is smaller than x. So the denominator is smaller than numerator. So this means that t is greater than 1. Right? Because the numerator is bigger than the denominator. Okay, so why do I do that? Because now I can say that this part here is t, and this is the inverse of this. You invert it, it's 1 over t. And you got these two unknowns brought into a single unknown. Then I can calculate because I've got an equation which I can solve. So I've got t plus 1 over t is 8. If I multiply right throughout by t, I get t squared plus 1 equals 8t. Now this is a quadratic equation, and I'm sure all of you have seen this, and there are two solutions. T is equal to minus b plus or minus square root of b squared, which is 8 squared, 64, minus 4ac, minus 4 times 1 times 1, all over 2a. All right? And this is 8 plus or minus square root of 60. The square root of 60 is 4 times 15. So I have 8 plus or minus. The square root of 60 is 4 times 15. And square root of 4 is 2. So this is 8 plus or minus 2 square root of 15. I'm taking out square root of 4 out from there, and the square root of 15 is still there. That's divided by 2. So you have 4 plus square root of 15 plus or minus. You can cancel the 2's, the top and the bottom. Right. And this is t. Now, one of these is 4 plus root 15, and the other is 4 minus root 15. But you want t to be greater than 1. 4 minus root 15, you can see it's going to be 4 minus 3 point something, and that is smaller than 1. So therefore, your t is actually 4 plus root 15. Right. So I've calculated t, but now what about this? How do you calculate this? Now I've calculated x over y. So how do I go around trying to calculate this fraction here, x plus y over x minus y? Now there's a nice trick to this. See? So I got the value for t. Right. Now x plus y over x minus y. Now x over y is equal to t, so that means that x is equal to y times t. Right? So I can replace x here by yt plus y over yt minus y. Lo and behold, the y's are taken out as a factor. And this quantity that I'm looking for is entirely in terms of t plus 1 over t minus 1. And there's t here. So t plus 1 is 5 plus root 15. And t minus 1 is 3 plus root 15. So that's the answer to this problem, x plus y over x minus y. But they might have asked it in a different way. Right? If this is asked you what this is, then this is the answer. They could have asked it as, what is it if you write it as a plus b root 15 without the denominator? Right? They could have asked that. And but now you got a denominator. How do you get rid of the denominator? So there is a way of doing that. You say that this is 3 plus root 15. Multiply the denominator by 3 minus root 15, because that's a very powerful a plus b into a minus b gives you 9 minus square root of 15 squared, and that is minus 6. So when you multiply the denominator by 3 minus root 15, the root 15 dies. So you multiply numerator and denominator by 3 minus root 15, simplify it, and then you would get an answer which is like this. So you can actually try it. The answer is actually 1/3 root 15. You get a very nice answer. This is actually simplifies to 1/3 root 15. And you can get that by multiplying numerator and denominator by 3 minus root 15. You have to multiply, these are equivalent fractions. You must multiply numerator and denominator by the same amount, to make them equal. Okay, so that's the last problem, guys. And thank you very much for being with me till the end of this tortuous exercise. I just want to see. Ingaha Emanuela says 12 square. So the answer is 12 square, right? Okay, that's great. And the same guy says B is equal to 2A. Yeah. So Ingaha is giving me some nice suggestions here. He calculated B to be 2A. All right, now those of you who put posts here, you can remain, and the others can go if you want to, but I'm going to answer these questions. They might be useful for you. Ingaha says 12 square. You remember the one about 2048 and so on? So he says the answer is 12 square. Okay. Then he also says B equals 2A. There was, if you remember, I had all these squares sitting inside a bigger square. Somewhere along the line, we got B equals 2A. He managed to discover that quickly. And it also says that M plus P is less than the cost of the pi. I said M plus P plus 7. Okay, thanks. I wrote the wrong thing down. The cost of the pi is M plus P. I put M plus P plus 7. That's why I was struggling with that one and found some other method of using trial and error. So thanks very much. So you must try that now. I made a mistake. I said M plus P plus 7 is less than the cost of pi, but it's really M plus P because these people had M rands and P rands respectively. When you put them together, you get M plus P, not M plus P plus 7. Thanks, Guy. And then Owen Slack said, excuse me, sir, I think you left out question 7. I'm not sure if that was intentional or not, but I thought I'd let you know. All right, I'm not sure. I think, let me go back and look at question 7 now. And then Nehal says, sir, you can solve this through an inequality, letting the cost of the pi be x. Oh, right. Right, so this Neha, he says you can solve this through an inequality. Actually, this is the solution that I had originally. I hope, Neha, you haven't peeped into my solution because it's exactly the same solution that I knew. Because the trick is there's a few coins, and very few people would have noticed that few coins means more than one. If you tried it this way, you will see that one is a possibility that Mbali has got 1 rand, but since the question says each of them got few coins, so Mbali has got more than one. So if you discover this on your own, that's excellent. But if you've been looking at some solution of mine, then it is plagiarism. Okay, now Mabe says, can you please send the recording on the group? Yeah, David will do that. David, you recorded this? Or belts and 2 hats? Okay, thanks, David. The total cost of 4 shirts, 4 belts, and 2 hats is 560. So I'm going to let the cost of 1 shirt be small s. This is small s is the cost of a shirt, B is the cost of a belt, and H is the cost of a hat. So 4 shirts will cost 4S, 4 belts will cost 4B, and 2 hats will cost 2H. The total cost is a sum of those 3 costs, and that'll be 560. While the total cost of 9 shirts, 9 belts, and 6 hats is 1,290. Okay, so what is the cost of 1 shirt, 1 belt? So the question is, what is S plus B plus H? Okay. All right, so it seems that we need to calculate what S, B, and H are. And then once you do that, then you can calculate this sum here. But I only got 2 equations and 2 unknowns, but they can be brought into one equation. Okay, you got 4S plus 4B, right? And here you got 9S plus 9B. So why don't I let X be equal to S plus B, right? Then in that case, the first equation becomes 4 into S plus B, so that becomes 4X plus 2H. Four into S plus B becomes 4X plus 2H. So this is 9 into S plus B, so that's 9X plus 6H. And this is 560. And this is 1,290. So you could have actually replaced these 2 unknowns by a single unknown. And that makes this into an equation. 2 equations and 2 unknowns we can solve. And you can divide by 2 the first one. You'll get 2x plus h equals 280. And the second one you can divide by 3 right throughout. You see 3 goes into that. So that's 3x plus 2h equals 430. All right? So you can subtract here now. If you subtract this that way, or if you want, you can play minus x. Just subtract, don't eliminate. I'll tell you why, because we need to calculate x plus h, you see. X is S plus B. I need to calculate x plus h. And I noticed that this is 1 more than that, and this is 1 more than that. So if I subtract, I got x plus h is equal to 430 minus 280. I could have taken a shortcut and come to the answer very quickly. Or if you didn't like that, you could have eliminated x, eliminated h, calculate x, calculate h, and then you can work out x plus h. Could have done it that way as well. But if you are observant, you will see I don't have to do all that. I need to calculate x plus h. If you have the goal in mind, then you can see I can calculate x plus h immediately. So the answer to the question is 150 rands. Okay. Thank you, guys. Those people who have remained behind, now you've got all the answers. Okay, if there are no more questions, we will close it up. We've got one chat question here. Oh, thank you, sir. Okay, user, make sure you do what you have to do. And next time, keep your mic closed. All right. Okay, David, I'm sorry I overindulged and just